Hey, Unit 6, Mom. Here we go. There's only three questions, but the second one's pretty lengthy. Let's rock. This first question is a discrete random variable. Discrete simply means that there are a finite number of outcomes. In this case, there are four outcomes, just 5, 6, 8, and 19. And then it's a probability distribution because fives occur 12% of the time, sixes occur the most, 69% of the time. Eights looks like they occur the least often, 8% of the time, and so on. So if we want to find the mean, this is sometimes called the expected value, okay? We can look at the calculator. Well, we can do a couple ways. First of all, if you want to take a gander at your College Board formula sheet, we will be spending most of our time right here. There's the bell, right here. Okay, so the first question is a discrete random variable. So the expected value or the mean is this formula, and here's the standard deviation formula. This one is a lot. I wouldn't do it by hand. I'll show you how to do it on the calculator. This one you can do by hand. This, you take every individual outcome times the probability of that outcome, and then you sum them up. So, if you wanted to show your work on this by hand, you would take 5 times 0.12, and you would say the mu of x is 5 times 0.12 plus 6 times 0.69 plus, and then you can do dot, 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 and just do the rest on your calculator by hand, like this. So 5 times 0.12, whoops, I don't want to be writing there. 5 times 0.12 plus 6 times 0.69 plus 8 times 0.08 plus 19 times 0.11. So I'm getting an average of 7.47. Now this is the variance, and this is the standard deviation, right? Just remembering what those symbols are. So we're going to get the standard deviation first, and then we'll simply square it to get the variance. And again, the formula is crazy. If you really wanted to get into the standard deviation formula, we can chat about this for a minute, but then I'm going to drop it and let the calculator work. Is for every outcome, so for the 5, I'm going to ask myself, how far is the 5 from my average, from 7.47? Then I'm going to square it. And let me see. Let me go back to my College Board sheet and remind myself. Oh, yes. Okay. So that's this. How far am I from average? Then square it. Then multiply by the probability of that outcome. That's the part I was blanking on for a minute. So the probability of that outcome is 12% times 0.12. And then I would have to do that for all four outcomes. So for the second one, I would do 6 minus 7.47 squared times 0.69, okay? Then I would add up the last couple, and then for good measure, it all gets square rooted. So, that would be your showing your work, okay, for sigma. Now, the calculator thankfully does this for me. If I go to my stat edit, you can put the data in like that, put your data in, take time to double check it, and then you go to stat calculate, and you can do one variable stats, not two variable. This is not two variables. There's only one variable. The variable is x. So it's a one variable stat, and you do list one based on, comma, list two, the probabilities in list two. Some of your calculators will say it'll say frequency list or freak list like this, and you'll put L2, okay? Then it will spit it out for you. So there's the 7.47. That is the same thing as X bar, okay? Sigma is 4.107. I don't know how round to 1 decimal place, so 4.1, I guess. And if I'm being careful, my average would be 7.5. Then to get the variance, I just square this. I'm a little suspicious. Do I need to just square this, or should I square that big decimal, the whole thing? So I would maybe write out more values of this, and I'll try it both ways. So 4.1 squared is just that, so that would be my first try, 16.8. Then I'm going to do the how thing and square that. Yeah, because that one, I'm going to say or 16.9. So I'm not sure which one the mom will accept. Okay, then it says, what's the expected value of x? That's just a repeat question, folks. That's the 7.5. All right. If we perform the following transformation to the x's, what is the new mean and the new standard deviation? We are going to do 4 times x plus 2. So we're going to take all of the x values and they get multiplied by 4 and added 2. What will happen to the center, the mean, and what will happen to the spread? And here's some rules that we've talked about, right? Multiplication affects everything. Addition only affects the center. So if I add 2 to all of these numbers, 5, 6, 8, and 19, well, I would then have 7, 8, 10, and 21, right? They are all bigger, so the center has gone up, but they are not more spread out. From 5 to 19 is a range of 14. From 7 to 21 is still a range of 14. So the spread does not change with plus 2. So long story short, when you do the center, you do the whole shebang. You take 4 times your previous center, 7.5, and then add 2. Take out your calculator, crunch that out. I think for me that's 32. When you do the standard deviation, you only do the multiplication. So I'm going to do 4 times 4.1, the standard deviation. Okay, so for me that would be 16.4, and you'll have something similar. Okay, the next question, this is getting into mostly binomial distributions. On your College Board formula sheet, we are going to be living right here, okay? The first question is geometric, and then all the rest are binomial. So let me read it to you, or you probably already read it yourself. We've got people that have brown hair. Look at that, okay? 34% of all people have brown hair, it says. I have a sample size of 14. You probably have a different p-value. So it says here, part A, when do you expect to find the first person with brown hair? This is the only question in all of these that is a geometric question. You may remember maybe bins versus bits. Bins is binomial. Bits was geometric. The only difference was the n versus the t. N is a set sample size, a determined sample size. T was try until you succeed. And that's what we're doing on the first one. We're going until we find the first person. And when you see the word expect over and over, folks, that is mu. That is the average. That is the mean. So back to the College Board sheet, you're like, I don't remember how to find that. Good news. There it is right here. You just take 1 divided by P. And P, for me, was 0.34. giving me 2.94, and it wants 2 decimal places, okay? All right, so that's it. After that, we are moving on to binomial. So I said from this line down, it's all binomial because if you see them all, we now are looking at the 14 people, and what's the probability that exactly 5 of them have brown hair? Like 5 of the 14. So this is binomial on your cheat sheet. This is the formula that you're going to be doing or referencing. The red part, remember, is NCR, okay? And here's the average and here's the standard deviation, which will come up later. Oh, before I forget, I should go to the calculator. Let me backtrack. There is a geometric button for part A. If you go to the distribution menu, second distribution, if you see down here, see Geomet, PDF, and CDF. Geomet PDF, you put in the probability of success and when you want it to happen. So this says, oh, I guess this doesn't do the average, but we could say, what's the probability it happens on the 4th person? The 4th person is the first person with brown hair. Well, that happens 9% of the time. You could say, well, what's the probability it happens on the 2nd person? Oh, that'll happen 22% of the time. Kind of interesting. What if I go all the way to the 10th person? What's the probability it will take that long? Whoa, not likely. If I go to my distribution menu again and pick the CDF button, the difference now is it's cumulative. So if I put a 2 here, it's saying what's the probability? Actually, I might put like a 4. What's the probability that the first person you find with brown hair happens before the 4th person? So it happens with the 1st, the 2nd, or the 3rd person. It adds them up. Okay, it's cumulative. All right, back to part B. The probability that exactly 5 people have brown hair. So I wrote down the formula here ahead of time. So the probability X equals 5. So we have 14 people. I want 5 of them to have brown hair. So 34 is my success rate. I want 5 successes, meaning I want 9 that don't have brown hair. Remember, 5 plus 9 is always the total sample size. This would be what you would write out if it was an FRQ. You could do this on the calculator. You 14 math, probability, see the C button right there, 14C5, and then multiply the rest out by hand. The benefit of doing this is you really understand what you're doing. So I get about 21, 22%. If I want to use the distribution button, it's a PDF because it's exactly 5 people. You put in the number of trials, followed by the probability of getting somebody with brown hair, followed by how many people you want with brown hair. And there it is, the same exact answer. Just be careful putting your answers in. I think it wants 2 decimals for all these. C, it says less than 7 people have brown hair. So the difference here, when it's less than 7, right? If you were doing an FRQ, I'd say, okay, first I'd take 6 people because less than 7, right? Let me just cheat here. I'm going to just duplicate this, right? And I'm going to change this to 6 successes, meaning then I have 8 that don't have it, right? Plus it's less than. So then I'm going to duplicate this, slide it over here. Oops, I think I chopped off my 14. If you see what I'm doing, this is what I would do to show my work. So this would be changing my exponents to 14C5, and then 5 successes and 9 failures. And then I would do plus dot, 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 right? When I do the button, it's the binomial CDF button, because CDF is cumulative. There. 14 trials, 34% success, and then you put a 6, not a 7, because it starts at 6 and goes down. So there's your answer. And what it just added up for me was it added up 6, 5, 4, 3, 2, 1, and 0. 83%. All right, variations on this. More than 3 people will have brown hair. Okay, more than 3. So I've written out here like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 14. So more than 3 does not include 3. So I'm trying to add this up, okay? 4 through 14. The calculator can't do more than, okay? It can only do less than. Oh, my Apple Pencil's doesn't like me. Okay. My calculator can do the 0 through 3. It can do this with the CDF button. So then I would do 1 minus. So, right, on my calculator, I'm doing 1 minus binomial CDF, 14 people, 34%, and then 3, not 4. And that's your answer, or that's how you would do part D. Okay, part D. More than 3, I do 1 minus a binomial CDF. If this was an FRQ, you would have to still show your work. I think if you were very careful and you said 1 minus binomial CDF, they're very picky. Like when you do 14, I would say n equals 14, p equals 34, and the upper boundary equals 3. That they would accept that. You have to very clearly tell n, p, and the boundary. All right. E, expected value. Okay. Expected value is the mean, right? Oh, come on, Apple Pen. Apple Pen. And in your formula sheet, this is it. So if you're like, what formula sheet? Here you go. Oh, we're not there, Fag. Here. Right? Zaya, expected value, and the next question is standard deviation. So that's where I'm getting these formulas from. So all I got to do is n times p. So for me, that's 14 people times 34%. So you would expect 4.76 people to have brown hair. That would be the answer for me. Of course, you're going to have something different. Expected value, you're going to try to do that formula. So square root n times p times 1 minus p, like that. So 1.77, and I guess we're rounding these to 2 decimals still. G. All right, now G, it shifts gears. We change the sample size. We really increase it a lot. My new n is 402, and I want the probability, the binomial probability, less than 157. So I'm just going to use the binomial CDF button. My new sample size is 402. My probability of having brown hair doesn't change, right? The probability of people having brown hair is not dependent upon my sample size. Then less than 157. Be careful. That does not include 157, so I'm going to put 156. And you can do the same. So I'm getting 98%. So when I did the CDF button, I did my sample size, I did my P, and then I did 156. All right. H, use a normal approximation to answer question G above, and then it walks you through it. So we're still at 402 people. Okay. The expected value would be, so that's back to here, folks. So 402 times 34%. Okay. Expected value is 136.68. That is n times p. 402 times 0.34. Standard deviation, sigma, is the square root of 402 times 0.34 times 0.66. I'm going to round to 50, I think, right? 2 decimal places. Okay, the z-score would be, so because it says we're going to try to use a normal approximation instead of the whole 14C5 or 402C157, we're doing a normal approximation. So what I've got here is, let me come down here. I have created a curve. I have modeled this with a normal curve that is centered here, 136.68, right? If you remember this notation, n with a little parenthesis. And the standard deviation of this curve is 9.5, right? It's a normal distribution. And now I say, what's the z-score for less than 157? So 157 on this curve is above the mean. It's over here somewhere. I'm just estimating it, right? And I want to get this probability that it's less than 157. So what's the z-score? Every z-score is the number minus the mean divided by the standard deviation. Way back to chapter 2, right? Sorry, I was trying to scooch that over. So what do I have for my numbers? I have 157 minus 136.68 divided by 9.5. Equals divided by 9.5. So my z-score is 2.13. Okay, or rounding it 2.14. You will do the same thing with your numbers. So my z-score is 2.14. Now the probability of that. Since I'm using a normal curve, I'm going to use the distribution menu and go to the normal CDF button right here. And then I've got lower bound and upper bound, right? My lower bound is way down here at negative 99. My upper bound, I just found it, it's 2.14, right? So comma 2.14. If you have a 0 and a 1, you can leave it there for your mean and standard deviation. So that's my percentage. This green shaded area is 98%. Okay, and that's the answer to that one. Whew, that was a doozy. Last question. This is again about what happens when you combine data sets. We have two data sets. We have two variables. We have variable x and variable y. What happens if you were to just combine the data sets together? What would you get for the new mean and the new standard deviation? So means just do what it says. Okay, so that's the easy one. So x plus y, I would just do 10 plus 16. So the new mean is 26. Okay. If you had 5 x's in a row, you'd have 5 times 10, so you'd have 50. So the means we could go through and do pretty easy. If you subtracted all the x's from themselves, you'd expect nothing. 10 minus 10. X minus y, 10 minus 16, negative 6. And then we have 1, 2, 3, 4, 5. So that's 10 plus 10 plus 10 plus 10 plus 10 equals 50. Okay. Now, what about standard deviations, right? When you are adding data sets together, the standard deviation is affected, but you don't just add standard deviations. You, to find the new sigma, we add variances. The formula is this, the new standard deviation of like x plus y of the two data sets added together is the square root of the variances added up, right? This, and this are called the variances, okay? And you always, always, you never ever subtract variances, even if you're like, oh, but I'm subtracting the data sets. It doesn't matter. Standard deviation always increases whenever you are combining two data sets in any fashion. So on the first one, I'm combining x plus y. So standard deviations are 2 and 8. I need to square them. So 2, so 4 and so let me show the work. It would be the square root of 2 squared plus 8 squared for my data points. You have something else, right? So I know those. So mine is really just the square root of 68. So I'd have 8.25. Now, let me skip over, well, no. So 5 times x. This is really sneaky. This is more back to just transforming the x variable. This is not like combining data sets, okay? This is saying this is actually going back up to here. Remember this one? When I said I have my x's, I'm just going to multiply them all by 4. That took the standard deviation and multiplied it by 4. So this is a really, really subtle one that you can fall for if you're not careful. So this one, all you do is 5 times 2, so it's 10. That one is not combining data sets, right? It's not. It's not saying take data set X and combine it with a whole second duplicate of data set X. It's not doing that. That's what this is doing. This is saying take data set X and duplicate it 5 times over. Like have 5 repetitions of every number. This is saying multiply every single data value by 5. That's not the same thing. So might as well jump down to here and do this one. So this one is the square root of 2 squared plus 2 squared plus 2 squared plus 2 squared plus 2 squared, like that. Of course, you can speed that up. So it's 5 times 2 squared, and you have a standard deviation of 4.47 for that one. Now, the last two are subtractions, and this is counterintuitive. You're like, oh, okay, so we're going to deal with variances, and you're maybe thinking, well, I'm going to subtract them because I'm subtracting the data. But no, standard deviation and variance always increases when two data sets are being combined in any way. So you always add the variances. So here, I'm going to have the square root of 2 squared plus 2 squared. So the square root of 8. So 2.83. And then on this one, it would be the square root of 2 squared plus 8 squared. So interestingly, that's what I did right there. So it's going to be the same answer. I don't even need my calculator. All right, there you go. Bada bing, bada boom. See ya.